Okay, students, today we are going to start another unit. This is unit number 3. So, in this unit, we are going to have motion, proximity, and ranging sensors. So, under this heading, we are going to see potentiometers, motion sensors, inductive type sensors are LVDT and RVDT, resolvers, synchro, microsyn, encoders. We are going to see optical, magnetic, and capacitive encoders, and then accelerometers and GPS, Bluetooth, range sensors, RF beacons, and ultrasonic ranging. Reflective beacons, laser sensor, that is lidar. So motion sensors, there are actually two types of sensors. Any sensor in general we can brought under these two categories. That is proximity type sensor, that is non-contact type sensor is known as proximity type sensor. Touch sensors are known as tactile sensor. So any sensor can be brought under these two categories. So here we have contact and non-contact types. So contact type, a sensing shaft is in direct contact with the object being monitored, and that is contact type. The displacement of this shaft is then monitored by a sensor. This shaft movement may be used to cause changes in electrical voltage, resistance, capacitance, or mutual inductance. So angular displacement methods involving mechanical connection, the rotation of the shaft might directly drive the gears. The rotation of the sensor element, this generates the EMF. So non-contact in type, that is proximity type. Proximity sensors might consist of beam of infrared light being broken by the presence of the object being monitored. So that is, the object is the target for which we are about to measure displacement or any other parameter. The sensor then giving a voltage signal indicating the breaking of the beam, giving a voltage indicating that the reflected beam has been detected. Also be just mechanical switches which are tripped by the presence of the object. Motion sensors, brush encoders, an encoder in which brushes that make contact with conductive segments or a rotating or linearly moving surface convert positional information to digitally encoded data. This is a simple brush encoder definition. So the output from this is a digitally encoded data. In a digital data we are getting as output. Motion sensors, a movement is an integral part of many systems. So movement or displacement we can find in almost all objects. Measurements like strain, temperature, pressure, force can be brought to measurement of displacement in the ultimate analysis. Passive components, these are the building blocks of electrical system. Resistance, capacitance, and inductance can be used to construct devices for transducting displacement. Motion occurs in many ways or forms, in straight line, or it can be angular also. So straight line is known as translational displacement. Angular motion is about an axis is known as rotational displacement. Then we will move to part potentiometer. In short, it is known as part. The potentiometer is an instrument for measuring the potential voltage in a circuit. The potentiometer consists of a resistance element with a sliding contact. It is like this. So this is the sliding contact. Resistance element with a sliding contact which can be moved over the length of the element and connected. A constant supply voltage, that is Vs, that is supply voltage, this is Vs. Output voltage V0, so this is V0 between terminals 1 and 2, which is a fraction of the input voltage. So here whatever you are giving Vs, that is supply voltage, and you are taking out a fraction from these two terminals 1 and 2. the fraction depending on the ratio of the resistance terminal resistance between 1 and 2, between terminals 1 and 2 compared with the total resistance R of the entire length of the track across which the supply voltage is connected. So thus V0 by Vi equal to R12 by R. So R12 is the output resistance, and if the track has a constant resistance per unit length, the output is proportional to the displacement of the slider from position 1. So this is a simple part construction. So a potentiometer, a rotary potentiometer consists of a coil of wire wrapped around into a circular track or a circular film of conductive plastic or ceramic metal mix termed a cement over which a rotatable sliding cartridge can be rotated. Hence, the angular displacement can be converted into a potential difference. So this is a part here. It is as similar as, or we can say, the fan regulator is a type of part. The ceiling fan regulator is a type of rotary potentiometer. So it is consists of a similar construction, and linear tracks can be used for linear displacements. So here the rotary tracks and linear tracks. So both depending on this, we can classify the potentiometer as linear potentiometer or rotary potentiometer. So these are the three forms or configurations of potentiometer. One is translational, rotary and helical. So here this is translational, and this is rotary, and this is helical configuration of potentiometer. These are the three configurations of potentiometer. So construction, there are three forms. One is single slide wire. It is a very simple form of potentiometer. Wire wound and Sermet type. So the first one, single slide wire. It offers a stepless variation of resistance as wiper travels over it. Length or diameter is limited, so as small values of resistance, the resistance per unit length increased by decreasing the area of cross section of the wire. So this is very simple form. There are no wire wound around the slider, and it is just a plain type potentiometer. So next is wire wound. This is the single striped insulating card, and this is circular insulating card. Resistance wire is wound on a straight or circular card or a mandrel. Provides stepwise increase in resistance as wiper moves from one turn to the one turn of the wire to another. So imposes restriction on resolution of the transducer because it has the standard number of wounds here. So it has the limited resolution. So that is another limitation of this type. Next is Sermet type. So here resolution, the resolution can be calculated for rotational device. So here this is the wiper, this is displacement, this is winding, and resolution can be measured using this simple relation: 360 into 10 to the power of minus 3 into divided by pi nd. So here d is the diameter of the part. Higher resolution demands thinner wires, results in higher total resistance. Thus, resolution and resistance are interdependent. So here resolution and resistance are interdependent. By seeing this relation, we can say that. So here this is the resolution, and this is the displacement. So materials. Resistance elements: nickel chrome, this is known as nichrome, nickel copper constant, and silver palladium or some other precious metals are used as resistive elements. Diameter vary between 25 and 50 micrometer, annealed to avoid surface oxidation. So wiper elements are hard alloys like phosphor, bronze, beryllium, copper or other precious metal alloys are used. So they are shaped to possess minimum friction and maintain the film contact with the windings. So these are the wiper materials and resistance elements. So cermet, the precious metal particles fused into a ceramic base constitute cermet. So advantages: stepless variation of resistance offering a very high resolution, large power ratings because it is easily fusible, and low cost, moderate temperature coefficients, utility in AC applications, also hot molded carbon films, thin metal films used to construct parts. So next is the loading effects characteristics. The resistance element is excited with DC or AC voltage and input and output relation is linear. The resistance of the length is Xi. So Xi by Xt into Rp equal to Xi by Xt can be marked as K into Rp, where Xt is the total length of the potentiometer wire and Rp is the total resistance of the part. EI is the actual input voltage, E0 is the output voltage. The Thevenin equivalent resistance, the Thevenin theorem, actually it simplifies the complex type of circuits into simple circuits. So E0 by EI equal to 1 by 1 plus R0 by Rm. So here the R naught equal to K into 1 minus K into Rp. So if you replace that, you will get in terms of K. So E naught by Ei equal to K 1 plus K into 1 minus K Rp by Rm. So this is the relation, and we can see its equivalent circuit diagram here. So this is circuit arrangement. The Thevenin equivalent circuit diagram is redrawn here. So this is Ei and this is Xi, this is E naught, and this is Rp and this is Rm. So here when you redraw this diagram using Thevenin theorem, so this is a simplified diagram, and again this is the simplified diagram using the same theorem. Any linear circuit containing several voltages and resistances can be replaced by just one single voltage in series with a single resistance connected across the load. So this is the Thevenin theorem of simplifying the circuit diagrams. So using this, we are getting a simple circuit diagram here, and a characteristic curve that is Rp by Rm equal to Z, and when Z is equal to 0, you have almost a linear curve. When Z is equal to 1, a slightly curve, and this is more non-linear curve when Z is 3. So when Z value is getting increased, and the characteristic curve between E0 by Ei to K becomes very non-linear. So this is a simple characteristic curve. So the typical available power rating is 5 watt at room temperature. The maximum excitation voltage can be calculated from this relation, where P is the rated power. So Ei max equal to root of PRP into Vi. So this is for high sensitivity, the E0 and Ei should be high. Ei value determined by Rp and its power rating. To achieve linearity, Rp should be kept low when compared to Rm. So that is the linearity relation or linearity constraint. So advantages: inexpensive and simple to set up. Large displacements can be measured. Sufficient output to drive control circuits. Frequency response and resolution limited for wire wound but unlimited for others. So only frequency response and resolution for wire wound it is limited, but unlimited for other forms of potentiometers. So disadvantages are mechanical loading owing to wiper friction. So it is contact type. Electrical noise from the sliding contact, wear and misalignment owing to friction. Quick manipulation generates heat and associated problems. Wherever you find the heat, there will be more problems, or we can say the even material can burn out very quickly because of higher temperatures within the material. So here the potentiometers, and we see the textbooks. These are the books. You can refer. Deoplin is a very good book, and Patranibus is another book. So these two books you can refer for more details. And e-resources, these are the other resources we can see. So we will stop here. We will see in next session.